All right. So there will be 3 subjects we're going to be covering. One, how do we get these cloud-based technologies deployed on Azure Stack? You know, what is that infrastructure as code technology that we can use to actually get orchestrators deployed, for example? Another one is how do we solve the actual orchestrators? What are these orchestrators that we can run? What kind of things do we do with them? And the last one is how do we solve the problem of trust? In other words, how do we do things like blockchain on Azure Stack? So that's kind of a little bit different from orchestrators in general, but also a very important key open source technology that we're normally using on Azure Stack. So moving on here, some of the technologies we're going to be talking about is Kubernetes. There will be a lot of focus on Kubernetes directly and indirectly, because we're going to be talking about OpenShift. As you guys know, OpenShift is a great cluster. In his core is running Kubernetes, and all your applications, when you deploy and manage them via OpenShift, you are actually doing it on Kubernetes. The other one we're going to talk about is on Cloud Foundry. We're going to take a quick look at how that looks like and deploy an application in there. We're going to talk about Terraform. And Terraform is going to be that technology we're going to use to actually show you how you can deploy some of the infrastructure you need to actually get these orchestrators in Azure Stack. And finally, this is another area that we're working on, which is blockchain. And we're going to specifically look at how we did proof of work, which, as you guys may know, proof of work is a type of architecture you use for doing things like Bitcoin, which we all know about. We're also working on proof of authority, which is it's a project that's coming along. I'm not going to touch too much on that one, but pretty soon we're going to have that one as well for blockchain. So moving on this, why don't we talk about Terraform quickly? I'm going to do a brief mention of our the latest that we have on Terraform. The project that we have been working on is already public. The latest set of providers that we have for Azure Stack, Terraform providers for Azure Stack. At this point, we have completed enough providers that you can go and actually do some interesting things. Things like deploying an entire OpenShift cluster. That's not a trivial thing. You actually can do this right now. You can deploy a blockchain cluster. You can deploy a purely Kubernetes cluster if you want, or you can go into something actually smaller, like blockchain. And that will work. We have all the basic pieces for that. Another part, of course, is that I wanted to make sure that you guys are aware of is that all of that is open source. It's in a Git project. If you find any issues, you can always submit those there. And that's the way that we're going to be looking and managing those providers. So having said that, I'm going to let Ansel McBarnett come in, and he will show us a little bit of how this Terraform thing works on Azure Stack. So thank you.
All right, so let me quickly set things up here. Yep, number 6, great. All right, so again, by way of introduction, it's Ansel McBarnett, and I'm from HashiCorp, and let's demonstrate to you the first step that you would take in deploying Kubernetes Stack or other applications, as Walter mentioned, on top of Azure Stack. A number of you may be aware of HashiCorp and of Terraform itself, but Terraform, obviously, for those of you Terraform, how many of you are actually Terraform practitioners in the room who have heard of Terraform? No? It's a way in which you can establish a workflow to provision any application on any infrastructure for any application. So type of infrastructures you provision, obviously, would be your public cloud on public cloud, on private cloud, and I would consider Azure Stack to be hybrid cloud, right? Hybrid cloud where you can deploy on-prem with external services and establish a workflow where you can represent your infrastructure as code. I'm going to show you some examples along that. From a HashiCorp perspective, Terraform is not the only tool but we can also provide with security, with networking, with running your applications. So we enable organizations to provision, secure, and connect, and run any infrastructure as code. So the essential elements is to how are you able to enable a practitioner, someone who has no idea of Azure Stack, right? Who has no idea of perhaps how can I bring the benefits of Azure onto on-prem? How can I accelerate your development and your experience with this? Just as a great antidote, the colleague I was working on who developed a lot of what you're going to see here, he had no idea about Azure, and he had no idea about Azure Stack. And in fact, it took him only 4 days to build all the code that you see here. So this is not something, so originally I was the one to accomplish a lot of this, but I was pulled into another work, and I said, okay, here, someone who was a new colleague within an organization, he was quick to learn, and he looked at the examples, he looked at what needed to be deployed in Azure Stack, and he did it in a little about 4 to 5 days. So this is not something that should be daunting to you. You could pick up this very quickly yourself, as you would see. This is what we want to attempt to do. So within, what are we going to deploy? So imagine you want to bring in Kubernetes, OpenShift, Pivotal Cloud Foundry, potentially on-prem. You want to deploy this in your organization, in your data center. If what we want to set up here is an environment that represents a load balancer. That's one of the resources. We're going to deploy some networking. So we're going to deploy some VPCs with 3 subnets. One particularly for the master services. So those who know about Kubernetes will know those terminologies. The master services, master and infrastructure nodes. We're going to set up 1 or more nodes, worker nodes, or VMs, as you want to call it, to deploy your pods and deploy your containers. So we need 1 or more of those nodes. And we also need a storage subnet for your permanent volumes. Maybe you need to deploy a storage disk. Maybe you need to set up some sort of object store. So this is just a simple setup. Well, I shouldn't say simple, but maybe a rudimentary or a minimum valuable or setup that you would use potentially to deploy OpenShift, which will be coming up next. So let's go quickly into it. Close this down. Okay, let me increase my screen a bit more. So Walter mentioned the Azure Stack, Azure Stack provider. Just a little bit, this is available on Terraform's website, terraform.io. Just look at providers. And you'll see a number of resources we're going to use. We're going to be using network interfaces and route tables. We're going to be deploying on our Azure Stack availability sets so that we can deploy a number of these virtual machines. We're going to set up some load balancers and route tables and some storages. So here are the load balancers and some of the storages. Before I show you the code, okay, let's take a look at what's happening on Azure Stack. I do have something already running, okay? Because when I press the button, it will take about 8 minutes for this to complete. So I'm going to start the process, and while that is happening, while it's being deployed, and this is a test Azure Stack instance. Where is this? This is in Seattle, isn't it?
Yes, it is.
Yes, in Seattle. So we're going to deploy from all the way here in Orlando to Seattle. Mm-hmm. And while that is running, I'm going to show you some of the resources. Is that fine? So first, I need to deploy my infrastructure as code. I'm using GitHub. All my code is represented here in GitHub. And we will go through a little bit what that code entails. But then I'm going to be using Terraform to deploy that code. Okay? So here, this presented before you is Terraform Enterprise. Some of you guys may be familiar with Terraform Open Source. with Terraform Enterprise allows you to apply governance to your workflows, allow multiple teams within your organization to work together, applying certain ACLs, certain access permissions and policies upon your infrastructure workflow that you're deploying. So this is Terraform Enterprise. I am going to deploy, I have actually associated one of my workspaces with the repo of all my code. So I'm able to take the repo where all my code is deployed, and I'm associating it with a logical construct called a workspace. And what's a workspace? A workspace is simply an independent unit of managed infrastructure. So the diagram here that you see, this is an entire independent unit of infrastructure. So this entire independent unit, I'm going to deploy in one shot. And if I need to make changes to that state, let's say I need to add more than one worker nodes. I've deployed initially 3. I need to add 5 more. Then Terraform is able to manage all of that as an independent unit. And with Terraform, you're able to look at what your desired state is and compare with actually what is running and know the difference, and it'll be able to adjust accordingly. So I'm going to demonstrate initially deploying one master, one infrastructure node with 3 worker nodes. And then I'm going to show you what it means if I perhaps decide to come back and say, you know what, my OpenShift deployment actually needed 5 worker nodes instead of 3. Let's increase it to 5. That's the declarative approach with Terraform, where you are able to declare exactly what you want, your desired state and your end state, and Terraform reacts accordingly. So let's do that right now. So I'm going to simply, without you guys knowing anything much about Terraform, I'm going to provide some variables to my code. I'm going to refer to some naming convention for my Azure stack. So I'm just going to call it, in this case, Orlando. I'm going to deploy it in the Seattle region. Notice I'm providing certain credentials to my stack. There's a couple of keys that I've hidden, made it sensitive, and that's one thing with Terraform Enterprise. You do not want to deploy your keys in GitHub. How many of you have done that before? No, I wouldn't say that. You don't want those things to occur, especially so you have the ability to secure sensitive variables, as well as all the necessary variables that I needed. If you're familiar with deploying an Azure, you will be familiar with all of these environment variables. So there's a way in which I can set up in certain environment variables for your deployment. I've separated my security concerns from my infrastructure, which is pretty good to do. So all I'm going to do is to queue a plan. What this basically says, a queue plan says is, let me take a look at what you want to do and compare with what's out there. And I'm going to give you some feedback on what I'm going to accomplish. So I'm going to run, it's planning right now. It's pulling from my code, and which I'm going to look at. And let's expand this some more to see what's happening. It says I have 48 resources to deploy. So that simple diagram you saw actually incorporates 48 things, right? Now, you could have coded a lot of that if you wish. It will take you more than, it will take you more than 4 days, maybe, all right? You can code all of that in place, or you could have Terraform apply that for you. So it says I'm going to run something. I'm going to deploy 48 of these. Let's take a look at what it says I'm going to do. What are those resources? Well, I'm going to be deploying the availability set to run all my nodes on. I'm going to run one for the info node. I'm going to run for the master node. Okay. I'm going to also put a load balancer in place, right, for the master and the infrastructure node. And I'm going to set up a whole bunch of address pools with some NAT rules, all right? All of this is being done through the Terraform workflow. I'm going to also set up a bunch of network interfaces with ingress. I'm also going to deploy some storages. Let's go up, security groups. Okay. And I'm going to deploy some storage accounts, one or more storage accounts that are going to act maybe as a permanent volume with a bunch of subnets. So you can see all of this is done in one shot through Terraform. In addition, there are some policies that it needs to check, which I'm going to look at a little further. In fact, I don't want to blow up Seattle, right? I don't want to deploy and set up maybe a Bitcoin farm, unless I really intend to, in the Seattle infrastructure. So there's a way in which I can prevent certain team members who cannot have access to do certain things from deploying pieces of infrastructure that's not allowed as per policy for my organization. But for now, I'm good to go. All my policies have passed, and we will look at some of those policies. I'm going to confirm and apply and let that thing run. So I think that will run for the next 8 minutes. While that's running, let's take a look into some detail in what it's actually accomplishing, because I understood that this is a very technical audience, so you guys might just be disappointed with no code being shown. So let's go into, while this is running, let's take a quick peek to see if anything is happening. All right, so it has started already. So it will continue. Let's look at some of the code here. What's actually running? Well, first let's look at my main, and these are the Terraform files. I am declaring my Azure stack as a provider. That actually points back to this guy here. In fact, the GitHub, and this is all the documentation. So I am declaring here, and I'm saying, all right, there are a couple of things I want to have occur. I want some storage accounts. You guys see that here? And you just refer to the documentation. Now, this language is called ACL, okay, HashiCorp configuration language. It's JSON-like, but with all the annoying looking for all the commas and indentations and everything it does. You just declare what you want. And here I just want to specify, I want some storage accounts. I want one for the registry. I want one for disk. Okay, I set my types. That's essentially what this is doing. And next, I have something for network. This is all my code to develop my network. So I'm in my Azure stack, I'm looking at some subnet that is attached to a virtual network. Notice here's my name. It says I need to create a resource group. I should have showed you guys the resource group first. So now I'm tying this network to a particular resource group, and I'm tying these subnets to a particular virtual network, right? So this is how Terraform knows about dependencies. Notice I'm just declaring stuff, but as part of Terraform behind the scenes work using graph, okay, where it calculates which resources is dependent on another. And someone who may not be a connoisseur or an aficionado, maybe someone who is a professional in Azure and Azure Stack, I may not know how to do these things. But yet I can look at the documentation, I can read, and I can tell Terraform, you do all the work in defining, I know I want some security, I know I want some VNets, I know I want some subnets. You define and you develop the various dependencies for me. Of course, I need to know a little bit about security, obviously, as a demo. What is not a good demo unless you allow everything, right? So everything is allowed, all the ingress and all egress. But of course, you could restrict that as necessary. That's the network. And here, after the network, we're going to put some nodes out there. So I'm going to define some nodes, some virtual machines, and I want you to be aware of this count. I can decide, based on variables, and these are all variables, how many of these nodes do I want to deploy out there? And that's important there. I'm going to demonstrate that a little bit as I round off my talk. Each node will have a designated storage disk for the OS, one for data, and one for the OS. So I have a storage profile where I'm going to register some of these storages, but now I'm attaching it to my VMs. Essentially, that's essentially what's happening here. Looking and declaring a lot of the resources, putting it in what is called infrastructure as code. So now, because it's in GitHub, I can put a workflow around there with pull requests. I can push things. I can merge. And in fact, because I'm doing this with Terraform Enterprise, I can actually have webhooks occurring where if I make changes, someone doesn't have to go to this UI to execute. Where's the UI? Doesn't have to go to this UI, and it's still applying, it seems, to execute this run. I can actually do that all from GitHub if I need. So I don't even have to go through this UI. So it is still running and still deploying. While that is being done, here's what it's completed. If I go back to right here. Okay. While this is running, this is what what it looks like when it's completed. Okay. So the diagram that we see here now is laid down as the following: as an infrastructure node, as the master node, okay, and as storages, and here all the necessary network capabilities that you need, the 3 storages that I mentioned before, as well as all the other, here are the nodes actually. Okay, here are the nodes here near the storages, as well as all that is needed to put together. Now, once this is laid down, then you'll have laid down the infrastructure that folks who want to deploy OpenShift can deploy upon it. Can you do OpenShift deployment also with Terraform? You can, right? So you can leverage Terraform also in addition to, once this is done, access OpenShift providers to actually lay that deployment. And we also have, these are the list of providers that you have available, and you can also deploy anything else on top of that. We have OpenShift modules also that are available online. Okay, so while this is, I'm sure it's continuing running, and while that's being built, let's see how far it is. Okay, we will end this with a couple of quick demonstrations. Okay, so it looks like it's still building, and I think it will have a couple of minutes left. Let's do one quick thing. So let's look at some of the policies here. This is settings. Sorry, here. This is Sentinel. Sentinel is a feature with Terraform and Terraform where I can put policy as code now to restrict anyone from doing things that may be bad or I would consider as an organization bad. Here I'm going to allow my VM sizes to be only standard DS1, DS2, or DS3. If I decide to deploy something that is different from this, Terraform can stop me in my tracks before it is deployed, and that's key. Normally, a lot of times, the only way we could find out if things really were deployed according to our organization policies only after the fact. We go after something's deployed, and then we scour the infrastructure and see, is this correct? Is that size big or not? Here, this is a way in which you can actually enforce policies before it's deployed. You can enforce it by way of setting the policy to be advisory only. Maybe you just want to log the occurrence of such. Maybe you just want it to be soft override so that folks can, you alert that you're potentially going to be doing something that negates a certain policy, but then you allow them to confirm that they are acknowledged that they're going to do so and continue along the way. Or you could have hard mandatory where you actually prevent them from doing that deployment. So let's do one or two things, and let's do that right now. I'm going to put a deployment in place where I'm going to try to deploy this. My VM nodes, I said, you know what? I am the best developer in my organization. I deserve a very large, footprint, a foot size. All right? So here's a matter. I'm going to do one of those, and then I'm going to queue this, and queue this plan to run. Okay? So Terraform will go out right there and do, similarly, look and do a test of, go through your code and test against policy. Is this something that you really want to do? All right, so right now, it's pending because it's waiting for this other guy to complete. So if I had timed this properly, my other deployment should be complete momentarily. Okay, so that's wait to complete. So momentarily it should be complete there. While that is occurring, let's do one more test. So I'm going to have 3 or 4 deployments doing all at once. Here, lastly, in my OpenShift code, let's go back here. What I want to do is, I know that's going to be deployed. This is all my variables. I know that's going to be deployed with, where is the code? Yep, all right. It's going to be deployed with a certain number of node counts. What I want to do, sorry, I apologize. Let me switch to the Azure stack. What I want to do is, of course, never do this directly, make changes in your Terraform code. Hopefully you have some sort of a tool that you're using to deploy. But I want to deploy, I initially deployed with 3 storage nodes. I want to make a change and have 5 storage nodes be deployed. Okay, so this is what I want to do. So without using the UI, okay, I'm going to go through the standard committing. I'm going to normally, from best practice, you actually do it in another branch. So I'm going to propose a file page and create a new branch. I would say, let's say it's ignite demo, increase storage. Okay, all right. I am going to create, and I'm going to create a pull request. Okay, right now it is doing some checks. So what it's actually doing now is, right from GitHub, it's actually going and pull against the Terraform plan and do some checks to make sure, can I really do this? If you had policies that you set up that couldn't be done even from GitHub, it will stop you from doing so. Okay, there you guys see? And the reason why it stopped here, it's because somebody ahead of time actually put the D5, that large VM size that was not according to policy. So now an admin person has to go and say, what is being done? Because I'm looking at the policies. Someone who may have admin can look and say, why is this not happening? And you can see something has failed. It's hard failure. Why is it a fail? It's because if you look at this policy, the rule I said, the Azure Stack VM, somebody has applied a policy that is not allowed. Okay? So these are some of the things you can do while accomplishing some Terraform deployments. So let me end my discussion now by looking at my runs. Hopefully my previous run should be done. Here it is. Okay. All right. So previous runs, actually, previous run and deployed my entire infrastructure, which is right here, my OpenShift stack, right? So that's essentially what I've demonstrated to you. I've demonstrated the ability to use the Azure provider, which is, I think, version 4. We have done a great rev of that provider. It's now out. It's available to you for your test. You can write very quick Terraform code, infrastructure as code, place it in GitHub. You can use Terraform to manage and deploy that infrastructure in as little as 10 minutes, right? An entire infrastructure that you can use to run the Kubernetes. I've demonstrated doing a number of resources like load balancing, networking, storage, master node, infrastructure node, the worker nodes, the whole gamut that you can use to deploy. I've actually showed you how you can actually put policies in place to prevent folks from doing stuff outside of organization norms. I've also demonstrated the hooks with GitHub, so that even if you have no idea of anything, nothing to do with Terraform, if somebody set this up really well from an organization and a team approach, you can accomplish all of this just by doing normal pull and pull requests from GitHub, and all the policies will also be applied there. All right, so thank you very much.
Well, thank you, Ansel. Yep. Appreciate it. 7 quickly here. Well, thank you, Ansel. Now we're going to move to our next demo. Let me do a quick introduction. If PowerShell helps here. All right. Neat. So next, we're going to have Nicolas Matos giving us an OpenShift demo. That way, we're going to truly see what this looks like, having OpenShift running on Azure Stack. I wanted to touch on a brief introduction here to the fact that we have OpenShift Container Platform and OpenShift Origin quick templates, ARM templates available at GitHub, and you guys can play with them and provide any issues, and we can track those here and resolve them as they come along. So having said that, I'm going to let Nick come over and do his demo. I can bring up the environment you need right here. We can move it to the main screen. Yeah. Seems appropriate. Yeah, that's good. Thank you.
So who here is running any type of containers are you running production or development? Okay. Using any type of like persistent storage or really just stateless? Okay. So for those that aren't running containers, and you may or may not know, but if you look at a container, it's really an application with all of its individual dependencies written, for the most part, as code. You could either do source to image when it comes to deployments or image streams. There's lots of different ways to actually get deployments going. But the big thing is containers are really small, and the fact that you could actually deploy them on the fly and scale things up on the fly. You also eliminate the whole complexity piece, right? Because you're not deploying a whole operating system. So therefore, you're really saving time, and also you're probably making your operations people much happier, because operations people don't want to sit there deploying VMs all day. And within a VM also, if you look at it, there's like a fraction. It may not be that large of overhead, but it's still overhead. And when you think of 100 VMs or 150 or 1,000 VMs plus, you're actually having 2.5%, 3% overhead, right? So really, you're kind of like wasting money. You're not getting the best density that you could. You're kind of losing ROI. And as I mentioned, like the problem is really it's magnified when you have 100 plus, or when you talk about thousands of VMs, right? And so the solution to this in a lot of ways is containerization. And containerization is great for other things too, like accelerated DevOps, right? I think everybody's talking about DevOps nowadays. To me, DevOps has been around for just a few years, but I've always kind of felt that DevOps was like the future in a sense. So it's nice seeing people actually starting to adopt that. So when you're looking for a fast, cost-effective way to actually deploy your infrastructure, and that could be infrastructure in Azure, that could be infrastructure in Azure Stack within your own data center. So we see a lot of customers that are doing hybrid cloud deployments for the most part. And they want to take the technologies that they're deploying in their own data center and run those things in Azure. So maybe you do your development on-premise in your own data center, and you do that on, for example, OpenShift on Azure Stack. And then when you're ready to actually deploy your applications, you deploy them into Azure. So you don't want to actually have to pay the cost of running everything in Azure the entire time. Or maybe there's data sovereignty laws, right? So certain countries won't allow you to take data from within that country out, and so maybe you want to deploy clusters specifically in those geolocations on Azure or small Azure Stack clusters, right? And when you also think of like containers and microservices, I think it's really important to understand like there's the cost savings there, the resource efficiency, reduced complexity, et cetera. But it's really important the fact that you can actually take your infrastructure as code and deploy it anywhere, and it's completely agnostic of whatever the environment is. You're not having to drag around very large dependencies. You could actually deploy things on the fly, and your developers can actually call these things out as you're actually deploying the applications. And the last thing I kind of really want to touch on for the most part is, we get a lot of people who ask us, like, well, I could just run Kubernetes. Why do I need to run OpenShift? OpenShift sounds really great, has all these things like CI/CD pipelines and software-defined networking and the whole stack. But Kubernetes is perfect. That's all I really need. And if you actually look at what Kubernetes is kind of lacking in a sense versus OpenShift, you don't really have the long-term stability and support, right? No one's actually supporting you when it comes to you using vanilla Kubernetes. Most of the time, especially if you're running very close to bleeding edge community versions, the only answer is moving forward, right? And then you have to actually test your entire stack to make sure, well, do all my runtimes work with things along those lines? There's no third-party ISV support either. So if you take an application from a certain company and they only certify it to run on certain hosts or certain platforms and a certain container engine, and you start running this on Kubernetes and it breaks, maybe they'll help you, maybe they won't, right? It depends on the company that you're actually using for their software. And then, with OpenShift, like Red Hat provides all of our patches, our fixes, we own the whole stack. So we have everything from the virtual machine all the way up to the application layer. So you actually know that all of these things are going to work with one another. And from the security perspective, to me it's kind of scary because everyone's like, oh, I'll just take these applications, I'll throw them in the cloud and everything's going to be fantastic. It's going to be so great. And it's like, well, where did you get that image from? And they're like, I got it off the internet somewhere. I don't know if that's a really great idea, just grabbing things off the internet and throwing them in your infrastructure when you don't really know what you're actually deploying, right? So, whatever you're deploying in that container, is it going to compromise your infrastructure? We actually keep hearing about all these different companies that have, they've been compromised, whether it's via data or networking or whatever it is, but like specifically related to Kubernetes, Tesla had a huge security snafu where their Kubernetes dashboard was exposed publicly and got compromised, and they actually started deploying containers that were actually running Bitcoin mining. And so, we were in a sense kind of funding Tesla for a while if anybody was actually going to their sites or using any of their services. And then this has also happened with other companies too, like Weight Watchers and such. So I think it's really important. A lot of times people don't realize for the most part that you actually need a full validated stack, especially if you're a very large company, you're running high production workloads and you have very stringent SLAs. And then obviously, the idea is that you kind of want to have this cloud ambiguity in a sense, right? What I build in my own laptop, I want to deploy it into my dev and staging environments in a location, and then I want to take this code and I want to matriculate it up, to the cloud, right? And the only really way that you could do that is kind of having something that's a little bit more platform agnostic. And OpenShift, for the most part, can run anywhere that RHEL runs. Certified to run almost anywhere that RHEL runs, and I say almost anywhere because there's always small little asterisks, and I don't work in legal, so there's no like little legal jargon at the bottom of it. But the general standard is wherever RHEL runs, OpenShift can run because OpenShift runs on RHEL. Now that we have the acquisition of CoreOS, you can actually use CoreOS as well. So kind of cool. But let's go ahead and actually take a look at some stuff because I'm sure you guys don't want to hear me chit-chat all day. So this is the OpenShift Service Console. And if we actually take a look in our shell, we could actually do an OC get nodes. And these are the nodes that we actually have deployed. And this is all running on Azure Stack. So you can deploy to Azure if you want. You can deploy to Azure Stack if you want. It really depends on where you want to actually run these workloads in a sense. Federation will eventually come, right? But as we all know, there's certain issues or limitations with etcd and some of the Kubernetes things. So, and I forgot the actual project name, but Federation will eventually come, which will allow all clusters to kind of act as one. But we're not there yet, right? And if we do OC get projects, oops. We can see the actual projects that we actually have deploying and running. So in this case, we're going to do map it. And if we look at our resources, you see that there's actually nothing in here. One thing to note, if you want to see everything that's running in all of your clusters, you can actually append the dash all namespaces. So by default, right, when you create a project, you're creating a new namespace. The idea is that you're not actually having to share that namespace with other users unless they're specifically wanting to deploy in that specific namespace, right? So you could actually have all the same naming conventions and basically duplicate everything that you're deploying across multiple projects. And then usually developers, you want to give them access to certain projects in general. You don't want them taking their code and pushing it out into production. Per se, maybe you do. I don't know. That depends on how you deploy things. But usually I see like release engineers that are kind of responsible for taking that task and actually deploying these things. So let's take a look and see. And then if we do OC get routes, we can see we don't have any routes here. But again, same thing. If we specify, we can actually see that our Hawkular and Hiketi are deployed, all of our API servers. I think you were deploying at Shinko, right? Yeah, so he had deployed to Shinko. We have the Docker registry, obviously, that needs to be accessible, and then the registry console itself. And is anyone here familiar with Hiketi or heard of Hiketi? So one thing that we've really helped contribute a lot to is container native storage. The idea is that workloads being deployed don't always have to be completely stateless. You can use stateful and persistent storage on the back end, and it can actually be distributed storage. So like the way actually we have this deployed in a sense, if we do OC get nodes, oops. The way that we have this deployed, we get these three CNS nodes. Those are actually using extra disks, and we have a Gluster cluster that's actually created there. And Hiketi is actually responsible for talking to OpenShift from a RESTful-based API perspective and allowing you to provision volumes or request volumes on the fly. So for example, if we do Hiketi and we do a cluster list, we can see our Hiketi cluster. And if you do Hiketi topology info, you can see what our cluster is comprised of. So these are the individual devices that are actually being claimed, and then you can see over here if any of the storage is actually being used versus allocated and such. So you can actually see all your information from a Hiketi perspective. So let's go ahead and create a new app. Let's pull this one from Docker IO. Oops. Karate. Oops, again. Did you always find it difficult when you use someone else's laptop? Okay. We're just going to go ahead and try this. Because now I'm just getting lazy. Oh no. Not used to this shell either. Okay. And then if we do OC get pods, we can see that we're going to start a pod, and then we're actually going to tail this pod. But we're going to have to hurry because it's going to go fast. Yep, it's already done. All right, so that pod actually deployed really, 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 really incredibly fast. Let's go ahead and take a look at it. So the pod's actually already up and it's already live. If we look at the logs, we can see actually what it's doing. If we look at the deployments of it, let's bring up the latest deployment. And then obviously you can get into the terminal of it. So, and then if we want to, we could actually get into that same pod through here. So let's copy this guy. So this is just another way of actually getting into the pod. If you actually wanted to do any type of like debugging or whatever, you don't actually have to SSH into the host. We actually have remote shell that'll actually redirect. So let's go ahead and do OC. Let's look at our service that we just deployed. I don't think I have access to actually see that in this specific. Let's try this. So if we do OC describe, we can actually take a look at the service that's created. So the theory in general with Kubernetes is when you actually deploy a pod, it's not externally accessible, right? It's not routable in a sense. Now, if you want to make that routable, you have a couple different ways of doing it, right? You could go through the CLI or go through the UI. So you can actually go in here and you can say, okay, well, let's take this actual deployment and then let's go ahead and configure it for a networking perspective, or we could actually just expose the service. If you want to expose the service, you can actually just specify it this way. Let me pull it up real quick. There we go. So this command itself, you can actually run. So OC expose, what was it, SC? UC map it. And then we can see over here that it actually has exposed that application now. And if you go, it loads our application. And from the OpenShift console, if you wanted to, we can scale this up, we can scale it down. It'll go through the process of actually deploying all of its individual nodes. So you don't actually have to do everything through the CLI. That's completely dependent on what you prefer. For example, we could actually scale it this way. So if we do OC get DC, and then OC get RC, we can see the deployment configuration and then the replication controller. So specifically the revision of the application that we deployed, how many pods we're actually desiring, and then how many are actually currently running. And if we do OC get pods, that'll show wide. Oops. You can actually see the pods and where they're running. So we actually have two that are running on two nodes that are specifically hyperconverged. So those actually are running Gluster and also running the nodes themselves. And then we have a third node that's running on node number 1. So let's go ahead and what we want to do is create a volume. Because right now these are stateless applications, right? If we actually put any code in there, we deployed it, let's say we drained the cluster or whatever and killed it off, basically anything that's there is not going to be persisted, right? So we really can just say OC set volume, and then really based on that, Hikiti actually goes out and provisions it. So if you do a OC get SC, you could actually see that we have the default Gluster FS storage that's configured as the default. And then on the back end, you actually have the second Gluster FS storage. That's kind of like transient persistent storage in a sense. And then if we wanted to, we could actually write any of the data to that. That's pretty much it.
Cool. Thank you very much. So now basically shows how we can have our ephemeral apps running on Azure, on OpenShift, and then how I can actually associate storage to it and make sure the state of it is preserved and is on a distributed system like CNS fast. Well, thank you very much.
Yeah.
Thanks, Nick. All right, so let's move on to the next part. We have 23 minutes. All right. Getting the environment up in the right place. Ideal. All right. So the next step, you guys just saw how we used Terraform to deploy an infrastructure such as the one that will be needed for OpenShift. We saw how you could use OpenShift. Within OpenShift, we saw how you can allocate storage to an application on and off using CNS. Now we're going to look at something slightly different. You can also run Kubernetes. If you're a purist, if you're a developer, if you're just trying things out, if you want to just test on your Azure Stack cluster, your particular applications, we do have a marketplace item that you can download to your Stamp that gives you basically a Kubernetes cluster. This is based on the CS engine that you guys probably have seen before. So let's go ahead and do that. I'm in the Microsoft Azure Stack admin console. Once I'm here, I can go, and we actually were running this as a public preview up until the beginning of this week where we make it public. So you can go to Azure, add from Azure in there. You can type what you want. Let's see if the UI comes back to us. Taking a little bit, yeah, it's there. Once you start typing, you get it, it's right there. At that point, you, as an administrator, can go ahead and download this Kubernetes item, put it in your cluster, and then at that point, tenants will have access to it. Here it is. Let's go to our dashboard. We go to, say, create new resource, and go to our compute resources, and it is right there. Kubernetes cluster is in preview. Public preview at this moment. Select it, and you start getting in your parameters. The subscription, you can say, let's get started with a new resource group. It's going to be local, say OK. Again, I'm deploying a Kubernetes cluster. Here. Nice. All right, so at that point, you enter an SSH that will be appropriate to you, a DNS name. Oh, it's going to complain about validation. It does want to have a real SSH key. So let's give it a real one. All right, so it should be happy now. Yes, it's happy. Enter a prefix for your masters. You can decide what size you want, how many masters you want, what size you want then. You can decide your pools as well, your node pools, and what size you want them for. In this case, by the way, this is dependent on build 1808, where we actually release support for managed disks. You can actually deploy using managed disk, select it there. provide your service principal, and the version of Kubernetes you want. One thing that I wanted to highlight is that we have version 1.11 has been approved by Kubernetes. By that I mean by the Cloud Native Kubernetes, Cloud Native Compute Foundation. At that point, you say okay, and you move to the second set. Say you're set to go. Do some validation. Set to go. Obviously, I enter some bogus service principal. So if we try to create this one, it will normally not do it because the service principal, the credentials are not correct. So let's go to one that is already deployed. So this one is already deployed. It's a small one, and it has 3 nodes. It has a single master, and it has this VMD. So just to explain a little bit about these components, the VMD is a VM we spawn before the cluster, the Kubernetes cluster, is actually executed. So that virtual machine, the thing that it does is that basically it takes the ACS engine that you guys already know of, and it takes the parameters that you enter and creates a spec out of those parameters that the ACS engine understands, feeds that into the tool, and then that tool generates the ARM template to produce the Kubernetes cluster. So that way we actually abstract you from having to use the ACS engine. You go the manual way. If you go and search for ACS engine, Azure Stack, you actually will find that project, obviously, and you will find instructions on how to use it. But this is the easiest way to actually do it. It will be generated. At that point, the VM, you can remove it or you can leave it there and use it and install other tools in there and use it to access your cluster, for example. So one thing that we can actually do at this point is actually play with that cluster and check how things are, what sort of things do we find in it. So for example, we can check what services are there, what pods are there, and all nice spaces. Notice I had already gone through this cluster. I had already installed Kafka. So I have Kafka deployed there. We can actually, one thing that I did as soon as I installed this was Helm. Helm is very practical. A lot of you guys likely are already using that. And what I did was I actually deployed WordPress just to test something very basic, and something like Kafka just to test again other aspects of this. The whole idea is that you can create these environments, Kubernetes-based environments on your Azure Stack deployments, so that you can bring your data analytics, you can bring your data pipelines, your smart data pipelines, all through the week. You've been hearing this over and over again. The previous session was really about setting up and using services for artificial intelligence in Azure. A lot of these things you can actually do in Azure Stack, and you can actually take advantage of your open source tooling to actually go ahead and do those things as well. So, and that's really what this session is about. So if we were to actually do something there, in terms of setting up Kafka, for example, or seeing Kafka running, we can start by doing, a topic. You guys are familiarized with how Kafka works? We can copy here. Basically, with Kafka, which is a message managing system, you start by creating a topic. In this case, we are creating a topic. We're calling it in-night demo. All right, so once it's created, then you can have a session, for example, that listens on that topic. So whoever writes to that particular topic is going to be picked up by that session. So why don't we go ahead and actually make this session run and be listening to Kafka. That way we can actually test that our Kubernetes cluster that we just deployed actually is doing things. So there, at this point, we're actually listening on the in-night demo topic. And why don't we actually create a session to produce messages, or a producer that is called in Kafka terms. And let's make sure that that one is actually producing messages to the in-night demo topic. And yes, there is the topic, in-night demo. Enter. So at that point, it's simply ready, prompting you to type any message that you want. This is a simple app that is using Kafka inside Kubernetes, inside Azure Stack. So hello, Ignite conference. I type that. So like we say, anybody any session that was listening to that particular topic should get that message, and that's what we have there. So that's a simple way of looking into your Kubernetes cluster. I install Kafka in this case using a Helm package. So installing Helm is very simple. Installing Kafka, very simple. Playing with this, very simple. Your applications can come in, obviously, and deploy far more sophisticated things like the one we're going to be looking at next. So through the week, you've probably seen a couple of presentations where they show. Let me get my PowerPoint to a place. All right. So I actually took this slide. You guys may have seen the presentation from the SQL Server team from Travis, where he showed SQL Server 2019 running both on Azure and on Azure Stack. He was actually running off a Kubernetes cluster deploy exactly the same way that you saw me deploying one, or that you saw me showing you how to deploy one. A cluster very similar to the one I just showed you playing Kafka with. And look at, they actually deployed the entire SQL Server 2019 product. And in there, they have the master instance, which is an engine that abstracts querying, whether the queries are for structured data, SQL Server relational data, or non-structured data like Spark. And all of that is running out of a HDFS data nodes. So all of these items are actually running on a Kubernetes cluster, like I said, provided like the one I gave you. So let's actually take a quick look at that environment. I had it open a little while ago. Let's hope that it's still there. So let me bring that up. It's here. How many of you saw the SQL Server 2019 demo running off Azure Stack? None of you? Awesome, great. So actually I get to show you something, guys. Running out of time. So this is Azure Stack. In here we have a console, the dashboard, a few links to the particular applications. I just wanted to show you some of the details of it. So the actual resource group where the ARIS, which is the code name for SQL Server 2019 is. This is an actual Kubernetes cluster, again, deployed using our little marketplace item. And you see it has two big, these actually very large machines, two nodes and a single master. Again, this was deployed on a single node SDK. So you can actually take full advantage of that deployment with something like SQL Server 2019 and play with it. Again, you probably remember the VMD machine. You know, this is a machine that actually runs the ACS engine to generate the ARM template and deploy it. So it's the same characteristics. A couple of things that are happening here. So there is a deployment for an application called LOS, or length of state prediction. It's an application that predicts how long a patient will stay in this particular hospital. So their demo was all about having an application that will take advantage of SQL 2019 machine learning features to do inference on data provided for the data for the particular patient. So it will look at the history of the patient and it will decide how long it will actually stay. All of this, again, running on Azure Stack. And another thing that is running on Azure Stack in this case is it's outside the cluster. The Kubernetes cluster is deployed by itself, is the Power BI server. So which is interesting. We're going to take a quick look at both of them. So in here, we had the cluster from SQL. It shows the various roles. It has a controller, master instance, compute pool, storage pool, data pool. If you remember the slide that I showed you a little while ago, those are basically the same roles that we saw in the slide, which is nice. It's awesome to see it running there. By the way, this whole thing was put together in the last 3 weeks. You know, we got in a room with the SQL Server team, and we talked about, well, how about if we do a common demo together? You know, given that they were working on ARIS and they were based on Kubernetes themselves, and said, well, we have a nice way to deploy Kubernetes clusters, very simple. Can you guys, if we give you an Azure Stack environment, can you go ahead and do this? And they actually grabbed the marketplace item the same way they deploy it, deploy SQL Server, and there you have it. You have an application running on it. So if we look at the application itself, remember we're talking about having an application that was taking advantage of SQL Server 2019. If you select any one of these guys, and say, okay, do I want to admit this guy, this lady, Ana Fernandez, and I have some data about her. If I admit it, you know, what would be the length of stay for this lady? And there you have it. Giving her data, it does evaluate an ML regression model, and it predicts that it will stay 4 days in the hospital. The model itself was not trained in Azure Stack. The model itself was trained on Azure, again, using SQL Server, and was downloaded and used at the edge, in this case, on Azure Stack. So I wanted to show you guys that. Beyond that, there isn't a lot of other things that will be interesting, except for the fact that you, in this particular setup, this particular stamp of Azure Stack, we're also running Power BI, and this Power BI is again taking advantage of SQL 2019 to SQL Server 2019 to see the stats on the patients that they have in the database. So for example, if I want to see the stats about patients that are going to stay 6 days or longer, I can easily generate reports based on that, and in there also is actually broken down by various different conditions that the patients may have, and so that will give us an idea of the larger amount of patients that I have, and therefore me as a manager in the hospital, I'm going to be able to manage resources accordingly and schedule time and so forth. So that's a nice demo. They put it together again very quickly. I was really surprised, and our Kubernetes cluster worked really well. So something to realize is that the way Kubernetes works is that there is a cloud provider, right, for the various clouds. In this case, you abstract the various interfaces for the particular provider, the cloud provider, so that if you're running off Azure, it will know how to create the Azure artifacts to manage the cluster. If you're running Azure Stack, same thing. We created one of those cloud providers for Azure Stack, and again, that's the one thing that I mentioned a second ago that is Kubernetes certified already. So having talked about that, we can move on. We're running out of time, but we can do a quick demo of Cloud Foundry. So if I can have this environment move here, I'm going to touch base on that. We're only 4 minutes away from ending the session. So I wanted to show you, we have several things in this environment. One of the items that we have set up is a PCF resource group that stands for Pivotal Cloud Foundry deployed there. If you look at it, it's a minimum deployment of it. A minimum deployment of it will be about 85 different items. I use the instructions that are available on the web to deploy Azure, on Azure, or select Azure Stack and deploy in Azure Stack. We are going to be, or the Pivotal team is planning to make this simpler and create a little marketplace item so you can do something similar to what you saw before in this case. Once you have it deployed, let's actually, you're going to see for example, these are the various different roles that Cloud Foundry will have generated once you deploy something like the pivotal application services. And so if you look at that, and then you come to Ops Manager, and you look at pivotal application services, and in there you look at, say, resources, the same names that you saw in the various artifacts are basically the names that you find right here. All right, so great. Having said all that, one of the cool things that get installed once you deploy services is this application called Apps Manager. We're getting somebody fixing up the session here. The screen, something different. So have you noticed Apps Manager, Pivotal Apps Manager lets me see the applications that are deployed right now. Again, all of this is happening on Azure Stack. You can easily deploy more applications. In fact, I have a very simple app here called a sample app. It's Node.js based, but it's having something as simple as say CF or Cloud Foundry push. You'll have the application deploy. And by the way, the name is sample app Node.js. So we'll look for that one once it's deployed. Should be about to finish. And we are over the time. And if I refresh here, there it is. So it's a scratch for now, but that's because it hasn't finished deploying. It's still completing. Once it's completing, it's going to try to start it. And once it's started, it says starting. And it's done. So it should be running now. If we refresh, it's running. And it provides a route. You can go and take a look at that route. I don't have the right certificates installed. They're all self-signed, so you have to go through little hoops. That's a very simple app to show there. A couple things are installed in this environment. A good thing, because they're right there, I don't have to go very far away, are our templates for Ethereum blockchain deployment. So you can actually use these. They are documented. They're available in our Azure Stack documentation. Once you deploy them, well, obviously they are one of the things that it shows. It's going to deploy this documentation for two different deployments. One for a lead Ethereum blockchain, and then a member join for it. If you go to the particular consortium solution template, we'll show you. It's basically this. We don't have to go into details. We really don't have time. But I happen to have it running here. And here is this particular one is my lead blockchain consortium deploy. And this one is my member one. They're all forming part of the same blockchain. They're contributing to keep that blockchain safe. And one thing that I actually found that is very handy is this little plugin that I can use to simulate, or actually not simulate, create actual wallets. In this case, I can actually move Ether between the wallets. So I have 1, 2 wallets here. I can say send some Ether, and I can select one of the other accounts. I can say, well, here's an amount that I want to send, 3,000, and say next. Once it should ask me for gas, because nothing happens unless you actually put some gas in these transactions. So say 20. Once I have it, I say submit, and there it goes. It's going to take some time for the others to confirm, and both of them are going to be adding to these blocks to this blockchain. So these two should have the same blockchains, amount of blockchain of blocks. So 60,946. This one, yeah, they're in sync. So 65,000. If we refresh this one, it should go to 65. So yeah, they're all there. So we are actually out of time. But if you guys have any questions, we're more than happy to answer them. Again, we looked at, the first thing we look at is how do we deploy orchestrators using Terraform. We actually went over and looked at a deploy OpenShift cluster. We look at the details on how you manage this. We then look at a specific Kubernetes example using the marketplace item. We looked into an application, fairly sophisticated application, taking advantage of the Kubernetes deployment that we did, which is SQL Server 2019, just released this week. And finally, we did a very quick look into how you would potentially get a blockchain deployment using our documentation and templates onto your Azure stack. Any questions? Be more than happy to answer. Well, is that it? We're done, guys. Thank you very much. Appreciate it. Thanks.